Hello students, today we'll be solving problems using trigonometry. So first let's look at the unit circle. You know cosine, you know sine. Cosine's the x value, sine's the y value. Now tangent is a little bit harder, but we know that it is opposite divided by adjacent. Opposite is sine because it's y divided by 1, and y divided by 1 or opposite divided by 1 is just y or sine. Cosine, same thing, x divided by 1. So tangent is y divided by x. Or you could think of it as sine divided by cosine. Now let's look at 4 different places on the unit circle. For a unit circle, the radius is always 1, but that point could be positive or negative depending on where it is on the x-axis or y-axis. So y-axis, top is positive, bottom is negative. X-axis, right is positive, left is negative. Reminder, the first term is always cosine and the second term is always sine. So at those 4 places, cosine and sine are either 0, 1, or -1, depending on where they are on the coordinate plane. Now that we know sine and cosine, let's take a look at some of the other ratios and how we can find them. So here's a unit circle. At 0 degrees, once again, cosine is 1, sine is 0. Tangent, remember, is sine divided by cosine, so sine is 0 divided by 1 is 0. For secant, it is the reciprocal of cosine. Quick reminder, reciprocal means that the numerator and denominator are flipped, or you could take 1 divided by whatever it is. Both of those will find you the reciprocal. So for secant here, it is a reciprocal of cosine, so we have 1 divided by cosine of 0, or just 1 divided by 1, which is equal to 1. Cosecant is a reciprocal of sine. When you divide by 0, there is no answer, so you put DNE, which means does not exist. For cotangent, because tangent is 0, it is also 1 divided by 0, so DNE does not exist. All right, let's try it out for 90 degrees, or pi over 2. It is up here, cosine is 0, sine is 1, so that means tangent is sine divided by cosine, or 1 over 0. You could write it as infinity because it goes to a really big number. You could write DNE or undefined. All of those are okay for tangent. Just so you know, in Desmos, it will usually say undefined. Now let's look at secant, cosecant, and cotangent. Once again, it's just the reciprocal of cosine, sine, and tangent. So 1 divided by 0 does not exist. 1 divided by 1 is 1. Here is the tricky part. With tangent, it is sine over cosine. Sine is 1, cosine is 0. Cotangent is the reciprocal, so we flip it 0 over 1, so cotangent will be 0. If we wanted to think of reciprocal as 1 divided by tangent, so cotangent 90 is 1 divided by tangent 90, it's 1 divided by 1 divided by 0. Remember division, we could change it to multiply and then by the reciprocal. So the 0 and the 1 will be flipped and it'll be 1 times 0, which is equal to 0. The process for 180 and 270 are very similar, so just take a look at these if you need them, but just know that they will be negative because the x-axis and the y-axis there becomes negative. Since we're talking about positive negatives, I just wanted to mention something called all students take calculus. The x-axis and the y-axis tell you where they're positive, negative. The all students take calculus, all, means that all 3 ratios are positive here. For sine and cosine, they're both positive, so then tangent will be positive because the x and the y values are positive there. The second quadrant, S, or students, means that sine is the only one positive here. Cosine is negative. That would make tangent negative as well because tangent is sine divided by cosine. Now the third quadrant is T, and for take, all students take calculus. Cosine and sine are both negative. Tangent is the only one that's positive there because negative divided by negative is positive. In the last quadrant, cosine is the only one that's positive, sine and tangent are negative, so calculus stands for cosine is positive, and that's why we call it all students take calculus. So all of them are positive, sine is positive, tangent's positive, and cosine's positive. All students take calculus. All right, so take a look here with this unit circle with the special right triangles and their coordinate points. So with 30 degrees, with 45 degrees, and with 60 degrees, using the opposite and the adjacent and the hypotenuse sides, they found you already the sine and cosine values. Just be careful with quadrant 2, 3, and 4, there will be negatives, so right there it's a negative for x, which would make cosine negative, and if you go on the bottom, it will make the y value or sine become negative. Now that we've gotten a little bit more background knowledge, let's take a look at some practice problems. These look really hard, but don't worry, you just need to solve for the trig ratio, and then you can do the problem like you've been normally doing. Let's look at the middle one. So 8 cosecant of theta minus 3 equals negative 4 cosecant theta plus 9. What do? You combine the cosecants and you combine the numbers. For negative 4 cosecant theta, you add 4 to both sides, then 8 plus 4, 8 cosecant plus 4 cosecant is 12 cosecant. With the minus 3, you add 3 to both sides. The left side cancels, the right side, 9 plus 3 is 12. Then if you notice, it's multiply, so you just divide both sides by 12. Then you have cosecant of theta equals 1. We know in a unit circle that the hypotenuse is 1. Now, cosecant is hypotenuse divided by opposite because it is the reciprocal of sine, which is opposite divided by hypotenuse. So what does the opposite side have to be when the unit circle's hypotenuse is 1? It has to be 1. So now let's take a look at where sine is equal to 1. It's at 90 degrees, or we can say pi over 2. If you remember over here, we also talked about cosecant of 90 is 1. So the answer is 90 degrees or pi over 2. Here it tells us the answer has to be between negative pi over 2 and pi over 2. So this fits and it works. If they give you a different range, you're going to have to either add 2 pi or subtract 2 pi to find your answer. For these problems here, you need to find the side length. What you do is you find the angle and look at the side lengths. It is opposite divided by adjacent, so we will use tangent of 34 equals to opposite divided by adjacent, and we know that the opposite side is 2, so it will be 2 divided by a. Now that we've got that, we just solve for a and we will get our answer. So tangent 34 equals 2a, multiply both sides by a, and you have to then divide both sides by tangent of 34 to get a all by itself. Now to get a, just whip out your scientific calculator, type 2 divided by tangent of 34. Make sure you're in degrees mode and we will get our answer. We need to round to the nearest tenth, meaning just one decimal space. So 6 is bigger than 5, so we have to make the 9 one bigger. The next number is 10. Can't do that, so we move the 2 to the bigger number, so it'll just be 3.0. Now for this problem next to it, it is using radicals, so please remember to not have a decimal answer, if not it'll get you wrong. It is a 45, 45, 90, so it is a special right triangle. Opposite and adjacent are the same, so if you don't actually want to solve this, you could just say O is the same thing as A, which is root 22. So with special right triangles, it's usually pretty quick and easy. Now here are 2 examples where you need to find the angle from the side measurements. So find the correct angle first, then name the sides. So x there, you have opposite and hypotenuse. That means we use sine. And to find the angle, we use sine inverse of opposite divided by hypotenuse. Throw that into your calculator. Make sure you click sine inverse, type that all in, and it will give you your answer. And the answer is 60 degrees, so make sure you're in degrees, and we'll just write out that angle x is 60 degrees. That is it. Let's take a look at the next problem. So for this problem, same thing, opposite and adjacent. So we know with opposite and adjacent, we will use tangent. So tangent inverse of 3.3 over 6.4. Put it in your calculator and you can get the answer, which is 27.2767. It asks for the 10th, so that means 1 decimal place. So for 27.27676 blah blah blah, we round the 2 up to a 3 because the 7 is bigger than 5. So we have 27.3 degrees. On your last section of IXL, it asks you for 3 different things, either 2 angles and 1 side, or 1 side and 2 angles. It is exactly the same as what we did previously, but you just have to find all of the sides and angles for each triangle.